Please read the following problem. Part A, silicon tetrahydride. We will start by drawing the Lewis structure model. To do that, we need to first determine how many valence electrons it has. Silicon has 4 valence electrons and hydrogen has 1 valence electron. To get the total number of valence electrons, we add them together. So we do 4 plus 4 times 1 because we have 4 hydrogen atoms, which gives us a total of 8 valence electrons. We put silicon in the middle and the 4 hydrogen atoms around it. We start by putting the Lewis dots on the center, and we have 8 valence electrons. So this satisfies hydrogen and silicon's outermost shells. We can replace the dots with lines to indicate single bonds. For the VSEPR formula, we have A X subscript 4. A indicates a central atom, and the X subscript 4 tells us that there are 4 attached atoms to the central atom, which results in a tetrahedral shape, and it has an angle of 109.5 degrees. Part B, arsenic trichloride. To start with the Lewis structure, we again need to determine how many total valence electrons it has. So arsenic has 5 valence electrons, and chlorine has 7 valence electrons. To add them together, we do 5 plus 7 times 3 because there are 3 chlorine atoms to give us a total of 26 valence electrons. We start by putting arsenic in the middle because it is the least electronegative and the 3 chlorine atoms around it. We start by placing the dots in the center first, and then we fill the chlorine atoms. We still have one more pair of electrons, so we put that in the central atom. We can replace the Lewis dots in between the chlorine and the arsenic with lines to indicate a single bond. We have a VSEPR formula of AX subscript 3E. A indicates a central atom. X subscript 3 means that there are 3 atoms attached to the central atom, and the E tells us that there is 1 lone pair. This results in a trigonal pyramid shape, and it has an angle of slightly less than 109.5 degrees. Part C is sulfur dichloride. To start with the Lewis structure, we need to determine the total number of valence electrons. We know that sulfur has 6 valence electrons, and chlorine has 7 valence electrons. To get the total number of electrons, we add 6 plus 7 times 2 because there are 2 chlorine atoms, and that gives us a total of 20 valence electrons. We place the sulfur in the middle because it is the least electronegative, and the 2 chlorine atoms around it. We start by placing the Lewis dots in the center first, and then fill the chlorine atom. And we can replace the Lewis dots between the chlorine and the sulfur to indicate single bonds. It has a VSEPR formula of AX subscript 2, E subscript 2. A means that there's a central atom. X subscript 2 means that there are 2 atoms attached to the central atom. And the E subscript 2 means that there are 2 lone pairs. This results in an angular molecular shape, and it also has an angle of slightly less than 109.5 degrees. And finally, part D, we have iodine tetrafluoride. We know that iodine has 7 valence electrons, and fluorine also has 7 valence electrons because they are located in the same group on the periodic table. To get the total number of valence electrons, we do 7 plus 7 times 4 because there are 4 fluorine atoms. And we also need to do -1 because of the +1 charge that it has. That gives us a total of 34 valence electrons. So we place iodine in the middle and the fluorine atoms around it. We know that the fluorine has to have 1 bond because there are 7 valence electrons, so it only needs 1 more to fill its outer shell. Therefore, we place the last 2 remaining lone pairs around the central atom, and we also need to indicate that it is a positively charged. It has a VSEPR formula of A x subscript 4e, A for the central atom, x subscript 4 because there are 4 atoms attached, and it has 1 lone pair. This results in a seesaw shape, and it has angles between 90 and 120 degrees.